Solve each inequality. Use the method of table of signatures. Use the real line and the interval notation to show your answers. I'll start with A. X plus 2 over 2x plus 1 is more than or equal to 1. A common mistake in solving questions like this, which involve inequalities, is to multiply both sides by 2x plus 1 in order to get rid of the denominator and keep the sense of the inequality. This is not correct in general because we don't know the sign of 2x plus 1. If 2x plus 1 is negative, we would need to flip the sense of the inequality. Of course, it is possible to solve this inequality by multiplying 2x plus 1. But then we would have to consider two possibilities. Whether 2x plus 1 is positive, in which case we keep the sense of the inequality, or 2x plus 1 is negative, in which case we would flip the sense of the inequality. If we take this approach, we will end up a few inequalities combined by and or. And solving that problem is not easy in general. Instead of taking this approach, we follow a much more superior approach, and that is the method of table of signatures. In this method, we bring everything from one side of the inequality to the other side, so that on one side we would have 0. Let's apply this method to the inequality we have. Let's bring 1 to the left hand side. We would have x plus 2 over 2x plus 1 minus 1 is more than or equal to 0. We can now find the common denominator, and it becomes x plus 2 over 2x plus 1 minus 2x plus 1 over 2x plus 1 is more than or equal to 0. If we add the fractions now, we would have x plus 2 minus 2x plus 1 in the numerator and 2x plus 1 in the denominator, more than or equal to 0. And if we simplify the numerator, we get minus x plus 1 in the numerator divided by 2x plus 1 in the denominator is more than or equal to 0. Once again, we might be tempted to multiply both sides by 2x plus 1. But because we don't know the sign of 2x plus 1, we wouldn't know whether we would have to flip the sense of the inequality or not. We stick to the method of table of signatures. To make the table, we note that we have two factors. These factors are minus x plus 1 and 2x plus 1. We find the roots of these factors. The root of minus x plus 1 is plus 1. It's a number which will turn the factor into 0. And the root of 2x plus 1 is minus 1/2. We could find these roots by putting the factors equal to 0 and solving for the root. Now that we have all of the factors and all of the roots, we can continue with creating the table. We draw the real line. We shown the roots on the real line, minus 1/2 and plus 1. We draw these vertical lines from the root, and we draw a solid vertical line on the left hand side of the first root, and then we start listing our factors. The factor we generated minus 1/2 was 2x plus 1, so I write it first. The factor corresponding to the second root, which is plus 1, was minus x plus 1, and I write it second. Now that I have listed all of my factors, I write the quantity of interest, which is minus x plus 1 divided by 2x plus 1. Now let's see how our factors behave. When x moves from minus infinity to minus 1/2 to plus 1 and to plus infinity. 2x plus 1, our first factor, becomes 0 when x is minus 1/2. For any value of x less than minus 1/2, this factor is negative. For example, if you put minus 1 into the factor, you will see that you get 2 times minus 1 plus 1, which is a negative number. For any number after minus 1/2, the factor is positive. Now let's look at minus x plus 1. It is 0 when x is 1, and for any value of x less than 1, this factor is positive. For example, if you choose 0, you see that the factor becomes plus 1, which is positive. For any number after 1, this factor is negative. The expression we're interested in is the second factor divided by the first factor. If x is less than minus 1/2, the second factor is positive and the first factor is negative. The ratio would be negative. If x is equal to minus 1/2, the second factor is positive and the first factor is 0. The ratio would not be defined because you would have the 0 in the denominator. If x is between minus 1/2 and plus 1, both factors are positive. Therefore, the ratio would be positive. When x is plus 1, the factor in the numerator becomes 0. The ratio will be 0. For any x after 1, one of the factors is negative and the other factor is positive. The ratio will be negative as a result. Our question boiled down to this: when the ratio is positive or equal to 0. By looking at this row, we can tell that when x is between minus 1/2 and 1, including 1, the ratio is positive or 0. Therefore, this is the solution to the question. We can also write it in bracket notation, starting from minus 1/2, excluding minus 1/2, up to 1, including 1. We can also show this answer on the real line. Minus 1/2, excluding minus 1/2, up to plus 1, including plus 1. Now let's look at the second inequality. We have 1 over 2x minus 1 is less than 1 over x plus 1. We bring everything to the left side so that one side becomes 0. we will have 1 over 2x minus 1 minus 1 over x plus 1 is less than 0. If we find the common denominator, we would have 2x minus 1 times x plus 1 as the denominator, and x plus 1 minus 2x minus 1 as the numerator, less than 0. We can simplify the numerator to get minus x plus 2 in the numerator and 2x minus 1 times x plus 1 in the denominator, less than 0. Now we have 3 factors. These factors, if I list them in order, will be minus x plus 2, 2x minus 1, and x plus 1. The roots of these factors are plus 2, 1/2, and minus 1. Let's now create the table. We draw the real line and we show the roots on the real line. Minus 1, 1/2, and plus 2. We draw vertical lines from these roots. We draw a solid vertical line on the left side of the table, and then we start listing our factors according to the order of the roots. Minus 1 is the first root on the line. The factor generating that root was x plus 1, and I list it first. The next root is 1/2. The factor generating that root was 2x minus 1, and I write it next. And the next root is plus 2, which was generated by minus x plus 2, so I write it next. And now that I'm done with listing all my factors, I will write the quantity I'm interested in, and that was minus x plus 2, the third factor on the list, divided by the product of the other 2 factors, x plus 1 times 2x minus 1. Let's now see how our factors and the quantity we're interested in behave as x moves from minus infinity to minus 1 to 1/2 to plus 2 to plus infinity. When x is minus 1, x plus 1 is 0. Minus 1 was the root of x plus 1. For any number of x less than minus 1, x plus 1 is negative. For any number after minus 1, x plus 1 is positive. Let's look at the second factor, 2x minus 1. It is 0 when x is equal to 1/2, because 1/2 was the root of 2x minus 1. For any number less than 1/2, 2x minus 1 is negative. For any number after 1/2, 2x minus 1 is positive. Now let's look at our third root, minus x plus 2. It is equal to 0 when x is equal to 2. For any number less than 2, this factor is positive. And for any number after 2, this factor is negative. Let's now look at the quantity we're interested in, the original expression we had. This expression is the ratio of the third factor divided by the product of the other two factors. If we are in the first block, that is all the numbers below -1,